Okay, you guys just finished watching glycolysis, the bottom line, and several things happen during glycolysis, and let's just remind ourselves. A 6-carbon molecule of glucose gets split into 2 3-carbon molecules of pyruvate, and the most important thing that happens here is that the electrons that from this bond that hold together this molecule get loaded onto NAD+, and then NADH is the reduced form of that molecule. So that's something that I wanted to make sure we understand. Also, in glycolysis, we get a little bit of ATP. We get about 2 molecules of ATP per glucose that is split in glycolysis. All right, so what happens with the pyruvate? All right, this is going to be the question for this next mini video. All right, so pyruvate has to become modified before this molecule can go off into the citric acid cycle. Remember the citric acid cycle? It's the second step of cellular respiration after glycolysis. All right, but pyruvate isn't quite ready to enter the citric acid cycle. So the first thing that has to happen is we have to break off one of those carbons, and the carbon is going to leave as CO2, all right? So a carbon is broken off. Now, how many carbons do we have in this molecule? If one is broken off, then we have 2 left, right? But we have to add kind of like a molecular decoration to these 2 carbon molecules, and that decoration comes in the form of a molecule known as CoA, or coenzyme A, all right? So we'll talk about coenzyme A in a second. So what do we have so far? We've broken off a carbon and it goes away as CO2. And what do we get? What is liberated once we break a carbon-to-carbon bond? But electrons, right? So electrons can be loaded onto this molecule of NAD+. All right, now again, NAD+, when it does not have the electrons loaded onto it, is the oxidized form. And then when we load these electrons onto it, it becomes reduced into NADH. So reduction is gaining, NAD+ gains electrons and is reduced into NADH. Now, what happens with this NADH? Well, this is our carrier molecule, and I'm going to draw it with little wings. It can fly off to the inner mitochondrial membrane. All right, so we've got this 2-carbon molecule, 2 carbon molecules, and we have to load these. We have to decorate them. We have to put CoA onto these molecules. And with these 2 carbons stuck to a CoA, these are called acetyl-CoA. And this becomes a very good substrate or a very good starting material for the citric acid cycle. Now, where does the citric acid cycle occur inside of the mitochondrion? But it occurs in the mitochondrial matrix. So remember the mitochondrial matrix? If I draw a mitochondrion like this, kind of kidney bean shaped, we have the outer membrane, we have the highly folded cristae of the inner membrane. Well, the citric acid cycle is carried out inside this inner compartment, inside of this inner membrane. This is called the matrix space, and there are enzymes there that carry out these citric acid cyclical series of reactions. All right, and from there we get a little bit of ATP, remember, but the most important thing is that we can harness the rest of the electrons from this molecule that used to be glucose, that was converted into pyruvate and then converted into acetyl-CoA. This is going to be our big electron donor for NAD+ and FAD inside of the mitochondrial matrix. Okay, so we'll see what happens next in the next video.